Here's some problems from section 10.1, and this is number 1, and all they wanted you to do was, it says sketch the parametric curve and identify those which define y as a function of x. In each case, eliminate the parameter. Find an equation that relates x and y directly. So I already wrote these up, so you can just follow what's going on here. So this was x in terms of t and y in terms of t. So I just eliminated the parameter first. Well, first of all, if we want to graph it, we could try t equals 0, 1, 2, and 3. Actually, the domain, I didn't write that down, sorry about that, but the domain was going to be from 0 to 3, so I should have indicated that over here. Let's just say that the domain was from 0 to 3, and that was t. Belongs to this domain 0 to 3. That was given, so that's why I just tried values at 0, 1, 2, and 3. And then I just graphed it. So when t is 0, x is 3, and y is negative 3. When t is 1, 2 plus 3 is 5, and 4 minus 3 is 1, etc. So we got our values for y here, just by putting these values in for t in these two equations. So these are your xy coordinates, and then I graphed it, and we had a straight line. But actually it's a line segment, and that's one thing you can do with parametric equations is you can graph a line segment, not just a straight line. Okay, so that was the graph of the parametric equation. Put my 4 points here, 1, 2, 3, 4. T being 0, 1, 2, and 3. And then I eliminated the parameter just by setting each of these equal to t. Then they're both equal to t, they'd be equal to each other. Multiplying both sides by the LCD, which is 8. And then just simplifying it till we got y equals 2x minus 9. And then you can say that yes, y is a function of x. So that's all we had to do for that. Number 3, same idea. Our domain was t belongs to, t is between, let's see, what was the domain for t in this one? It was between 0 and pi over 4, which wasn't quite a bit. So say over here, t belongs to the interval 0 to pi over 4. So I kind of divided that up just to get at least 4 points. So this is what I did. I tried pi over 4, I said pi over 16, pi over 8, 3 pi over 16, and pi over 4. So I divided my interval from 0 to pi over 4 into 4 little subintervals. And then I tried these different values. X equals a tangent t, y equals a secant of t. So the tangent of pi over 4 is 1. And this is, that's our cat Buttermilk, so he wants to go outside, but he can't go outside, so just have to deal with him. Hope he doesn't bother you too much. Okay, so we just put these values in, and I looked these up on a calculator. So for these different values, these were the tangents of pi over 16, pi over 8, 3 pi over 16, and pi over 4, and these were the secants. So we just looked those up on the calculator, and then we plotted the points over here. And these are the approximate values, and this is my scale. This is 1, 1.5, 1, 1.5, and then we got that little part of a curve there. Actually, it's part of it looks like it's going to be a hyperbola. Okay? If you look at the rectangular coordinates, okay, that would be y squared minus x squared equals 1. That would be a hyperbola. Okay? And then so this is how we graphed it. So there's your table of values, there's your graph. And then the way I eliminated the parameter was, I know that if this was kind of hard, but I know that I do have this Pythagorean relationship. So I know that the sine squared plus the cosine squared equals 1. So if I divide everything by the cosine squared, I get this relationship, tangent squared of x plus 1 equals the secant squared of x. So that's what I was shooting for. So I know that if x equals a tangent of t, x squared equals a tangent squared of t. If y equals a secant of t, y squared equals a secant squared of t. So we started with this relationship, which we know from the Pythagorean relationship. And then I just substituted, so this was tangent squared was x squared plus 1, and the secant squared was y squared. And there we got rid of the parameter. And then we can solve for y by taking the square root, and y equals the square root of x squared plus 1, and that in this form, y is a function of x. Okay? So that's how I would do number 3. Hope that makes sense.